So on that first one, well, it is what we call expanded form. It starts in expanded form. I want to contract it. When we kind of bring it back in together, we call that an exponential form. How many twos are up there? 1, 2, 3, 4, 5, 6, 7. Yep, there's 8 there. So let's rewrite that because that's a long thing to write out like that. So we write that in a condensed version, which we call exponential form. So 2, and you said how many? 8. We rewrite that as 2 to the 8th. And again, what we call that form, we call that exponential form. Now, in that exponential form, it has two pieces. We have what we call as a base. We have what we call as a power. Which one is which? Which one's called the base? The 2 or the 8?
And then the 8 is the power.
Thank you. That's called my base, and that's called my power. Okay, letter B. We go back and forth, kind of like an accordion. Expand and contract. 3 to the 4th is an exponential form. Expand it out, please. How are you gonna? What's up?
3.
Rewritten 4 times, and when we rewrite that, what operation is happening there? Subtraction, division, multiplication. So we're gonna rewrite that with multiplication. 3, 4 times, correct. And that's again what we call expanded form. Making sure you can go both directions, because what we will be doing throughout this second semester and then next year in geometry, when you roll back into this stuff, you're going to have going back and forth. This idea goes a lot of different avenues. So make sure you can do the basics there. Okay, let's take the next one. Take it from expanded form, rewrite that in exponential form. Take a quick second, take 5 seconds, rewrite that in exponential form. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Okay, what does yours look like? It better look exactly like mine. Does yours look exactly like mine? Well, then it's wrong. What did I forget?
Until as many numbers in the equation, that's the power, and then whatever the main number is, the base.
Yeah, the one at the bottom is called the base, and the one at the top is called the power. But mine's wrong. If you wrote mine just like that, you wrote yours just like mine, yours is wrong too. You better have those parentheses. Exactly it. Okay? If you do not have those parentheses around there, if it starts off as parentheses, you better have parentheses around that. So, bless you. You better have those parentheses there. Okay? One of the big things we're going to keep talking about throughout these next 3 weeks is using those parentheses, especially when we get to the calculators here in just a couple minutes. Okay? All right, take letter D, expand it out for me. What are we going to have written there? We're going to have a bunch of 5s there or a bunch of X's there? Bunch of X's, because my base is what this time? Is an X. And how many X's? Thank you, Tresney. That's the Tresney we want to keep seeing here. Okay? That is correct. My base is X, my power is 5. Okay, now we get some different bases, don't we? We got some different bases going, and we got what on powers? How many 2's I got?
2. Because they're going to be 2 and 2, and then 3 and 3.
And then X and how many X's?
4.
4, right? All right. So let's get going here. On the 2's, Victor said how many?
2.
On the 3's?
3 to the 3.
An X to the. Now I heard somebody say parentheses, right? Okay. Now a second ago I said, hey, if you didn't have that parentheses around it, it was definitely wrong. Now I'm going to backtrack that a second. Why am I not going to be as picky on this one?
But multiple equations.
No, not so much that one.
Because it's not negative.
It's that dang negative. That is correct. If you put parentheses around that 2 and that 3 and around the X, you're okay. You're not doing anything wrong there. But on that previous one, Reese pointed out that one had the negative. The negatives will always kill us. So it's not a bad habit to always put parentheses around things. That won't ever kill you. But when you have that negative right there, that's the important part. Okay. But what you got there is the basics. Okay. Whoops. That's what we're looking for right there for sure. There's not a negative to worry about. Okay. And as you guys just told me, we have a base of 2, a base of 3, and a base of x, and a base of base. Nobody. That was just for you, Miss Kino.
Thanks.
You're
I
welcome.
appreciate it.
You're quite welcome. All right. It's an old one, guys. All right. Last one there. It does not matter on that one, Tristan. You can, or you don't have to, because there's no there is no negative. Okay. And on that last one, letter F, let's expand that out. I've got what, 3 bases there. I've got a 3, an X, and a Y. How many 3s are going to be written there?
1,
How many X's?
2,
How many Y's?
3.
Do I need to put a multiplication sign in between there? No, because if there's no sign in between there, what's always meaning that's in between? Multiplication sign in between there isn't there. Okay? So we're starting off with the basics like that. All right, let's take number 1 then. All right, let's make what we say is a conjecture. What's going on here?
It's 3 Y's, right?
Oh, I forgot why. Thank you. Call me out on that. Please do so. All right, don't forget that power of 3. Is that what you're saying to me, Isaiah? Thank you. Please call me out. That's what we're here for. All right, so let's take a look at this first table, this first column here on that table. Before we go and do this, we're starting off with positive exponents. And here's where the troubles always lie. I don't care who you are. All right, if you're really good at math or not, here's where the troubles lie. Right here, when I get to the 0, and then we get to these pesky negative powers. So this is what we want to start working on really today and through the next few weeks. All right, what does 2 to the 4th mean again in expanded form?
4 is 4.
2 times 4. 2 times 2 times 2 times.
There we go. So let's expand it out, guys. All right, now bring up those calculators. And I want you to go ahead and put in your calculator correctly. I know you can do it in your head, but go to your calculator and correctly put in 2 to the 4th. We haven't really done much, and I want you to actually put into your calculator 2 to the 4th power. Because at this point, we really haven't done much of anything outside of powers with that. Okay, we've done absolute values most recently, but how do we put something up to the 4th power? So first off, my graphing calculator people. Okay, calculate screen. Put a base of 2. Now, how did I get a 4th power here? Over here on the right-hand side, where you see the right above the division key, you see the up arrow. That's my exponent key. Hit that. Boom. Now you can see the exponent flashing there. Hit a 4. I heard Ari say what? We get a 16 there. Okay, now that's a nice one. You could definitely do. So 2 times 2 times 2 times 2 gives me a 16. My Desmos people. Okay, Desmos people, same thing's happening. All right, Desmos people, do the same thing there. Can you get 2 to the 4th? So 2, and then get that up to the 4th power. How are we getting that up to the 4th power? Right there where it says A to the B. The B means you can put anything up there. And then we hit 4, and it immediately puts a 16 on there. Don't just sit there and stare. Make sure you are typing in there and knowing that good stuff, because you are going to get a lot of different exponents up there today and this next 3 weeks. All right, let's run it down there. Get me all the way down to the 1st power really quick. Stop right after that, though, before we get to the 0. I know these are small numbers, but we're trying to see a pattern here, and we're going to try to make a conjecture of what's happening. So we got a 16 that happened, right? And then we got an 8. We got a 4, and then what's 2 to the 1st power?
Just 2.
Just a 2. Okay. Now we get down there, and what's happening on these 2's? What are we doing to these 2's here? We're dividing a 2, aren't we? We're losing a 2 each time, and what operation is doing that? Division, right? We're dividing by 2. 16 divided by 2, 8. 8 divided by 2, 4. 4 divided by 2. So before you go to your calculator, somebody, what's 2 to the 0 then to become?
0.
Ooh.
1.
2 divided by 2 is 1. So we kept dividing by 2, kept dividing by 2. Now go to your calculator. What is 2 to the 0 power? Calculator says what? It says 1. Okay? So it says 1. All right, let's keep dividing by 2.
Is it gonna be negative 2?
I don't know. Let's see. We're dividing by 2, right? We divided by 2. We divided by 2. We're taking 1 divided by 2. So what's 1 divided by 2, Victor?
0.5.
0.5, right?
Or 1 over 2.
Or 1 over 2. So on 2 to the negative 1 now, that's what we're going to get. We're not going to get a negative. That's where our brains are like weirdly hardwired to think we're about to get a negative number here, but we don't, okay? 2 to negative 1, what happens here is we get ready to get this one. We're about to get 0.5. We get 1 over 2.
And then 1 over 4.
Chill, but you are exactly correct. All right, so I'm going to type in 2, put it to the power, negative 1. Now, when you hit enter, my calculator says 0.5. And I don't want any decimals through the next 3 weeks. I want no decimals. So now, how do we change our calculator to give me fractions? Hit math. Get into this habit. Just like we did on my absolute values. It's all about practice. Right here where it says math button, option number 1 changes that decimal to a fraction. It changes 0.5 to a half. By decimals, people, your calculator does that. All right. 2 to the negative 1. Hey, there's that 0.5. For you guys, you just have to click where it says, well, make it a fraction. Boom. It changes it to a half. Okay. Now let's go to the next one. 2 to the negative 2. Bless you.
1 over 4.
Okay. 2 to the negative 2. Your calculators will always default to the decimal. Who cares? Math, option 1 fraction. I get a 1/4. Cool. 2 to the negative 3. Keep going with that.
Which is 1 over 8.
Again, decimal, math, option 1 fraction. Get to know that button because, man, we're going to use that button.
And then 2 to the negative 4 is 16, which
And
means it basically goes backwards.
It absolutely goes backwards, doesn't it there, Tristan? So what we have then is a pattern that's developing. Whoops, you said 8 and I did that. 1 over 8. So as we look up here for where we started and where we got going here, it is what we say is the reciprocal. Okay, it's the reciprocal. Reciprocal is flipping it. 1/4, 1/2, 1/8, and so on. All this is 2 squared. Okay, this is just 2 squared. This is what we do with these. The negative sign becomes in the denominator. It comes to the denominator. And this is what we want to practice on with you guys over, well, put the phone away, Victor. We'll just talk. Okay? This is what we want to get back with you guys on from your middle school years, where this should have been like immediately known, but it's not. Okay? With the 0 exponent rule. Now, let's carry that to the second column really quick. Okay, what do we have here? To the 10th power. Okay? Now, 10 to the 4th. All right? 10 to the 4th means 4 tens. Now, 4 tens, you can go to your calculator. 4 tens means I say, 1 with how many zeros? It's there, yeah, it's a 1 with whatever that power is. So 4 zeros. Okay? But what you should then start to see then is a pattern on, whoops, 4 zeros, on the next one. 10 is going to be a 1 with 3 zeros. A 1 with 10 times 10. 1 with 1 0. And then right here, what are we doing? We keep taking away a 0. We keep dividing by 10. And if you don't believe me, and you don't believe the pattern that you're doing, 2 to the 0 is 1. 10 to the 0 is going to be, yep, 10 to the 0 is going to be 1 as well. You're dividing by that base. You're dividing by that base. If it was 3 to the 0, 5 to the 0, whatever to the 0, it's always going to be 1 every flipping time. And then what we do is we say is the reciprocal. Tristan said it kind of goes backwards. Whatever you got for 10 to the first power, we're going to get what we say is the reciprocal, 1 over 10. What did you get on 10 to the second? 1 over 100. We say 1 over 10 squared, which is 1 over 100. What did you get on 10 to the third? It's 1 over 10 to the third, which is 1 over 1,000. Okay? That's what the negative reciprocal does. It never makes it negative. The only times it does that, we'll see in a few minutes, is if it starts off with a negative out front, but we're not dealing with that at the moment. Okay? She's singing?
Someone is.
All right. So let's try that. Let's take away that table there. Let's extrapolate that out. So somebody, how am I going to make that a positive exponent? I don't like negative exponents. In math, we have rules. And one of our rules is make all negative exponents positive. So if you see negative exponent, make it positive. So 5 to the negative 2. How do I rewrite that to make it positive? 5 over negative 2 becomes what?
5 over 2.
1 over 25. Look it up here at our table. All these became 1 over something. 1 over something. 1 over 5 squared. So you're going to, kind of a way that I always remember it is, cross the line, change the sign. Okay, 1 over 5 squared. And then somebody said, hey, isn't 5 squared just 25? So that's fine too. I would take either answer right there.
To be honest, I had no idea what you were trying to ask.
That's what I'm asking. Okay, 1 over 5 squared or 1 over 25. Either answer is correct.
Oh,
Okay.
sometimes we said for nothing.
Huh?
I always said answer for nothing.
I don't know. I don't know what you put. Okay, 1 over 5 squared or 1 over 25. Either answer is fine. I will take either answer. How about 3 over negative 2? What's that going to be rewritten as? 1 over 9 or 1 over 3 squared. Either answer is fine. I will take either answer. Now, that's an easy one you can do in your head. I heard somebody say 9. 1 over 9 is completely fine. 1 over 3 squared is completely fine. Okay, 7 to the 0. What we wanted you to start developing, like you guys have done over the school year, is rapid fire. 7 to the 0 is, yeah, you should see a 0. Anything to the 0 is 1. Okay, those you could all do in your calculator, but you can't do variables. X to the negative 2, rewrite it. 1 over, think of it as just like 5 to the negative 2. 1 over x negative 2 is, it crossed the line, change the sign. You change the sign of the power. 1 over x squared. Now there's nothing more you can do with the variable. 1 over x squared and call it a day. Okay? Anything to the 0 power becomes 1. X to the 0, 5 to the 0, 10 to the 0, y to the 0. Anything to the 0 power becomes 1. Negative 4 to the 0 becomes 1. Correct. Okay? Anything to the 0 power becomes 1. 7 to the negative 2. 1 over 49. 1 over 7 squared. Look at your table. I will take either of those answers. Either answer is correct. I will take either answer there. Okay? I'll take either answer. Put the phones away. Griffin, put it away. 3 squared. That's just 9. 3 squared is not going to get rewritten. Okay? Is that a negative exponent? No. So don't write it as 1 over. 3 squared is just 9. So don't write it. Don't be in that habit. Okay? Anything to the 0 power is just 1. And if you don't know those, you got your calculator, don't you? Okay, flip it. Let's keep running along here. So what I have right here is just a quick reference sheet for you. What did we just say again a second ago? 6 to the 0, anything to the 0, or let's go up here. Anything to the 0, a to the 0, anything is 1. So we can just run it across. Anything to the 0 is 1. Anything to the 0 is 1. Anything to the 0 is 1. Okay? Now later on down the road, we'll change it up ever so slightly where those negatives are, but we'll do that later. And then negative exponents. If that exponent is negative, we have to rewrite that. 1 over, in this case, we're going to generalize that out. We say, hey, keep the base as is, but change that power. Cross the line, change the sign. 1 over a to the n. The n changes its sign. Change the power's sign. So 6 to the negative 2. 1 over 36. 1 over 6 squared. That's a nice number to multiply. 36. That's correct. Okay, the base is negative 6. Who cares? 1 over negative 6. And as we talked about our last topic, whatever's on your paper, better continue to be on your paper there. It's in parentheses, isn't it? You better have those parentheses written. Don't get lazy on yourself. Those parentheses are going to save you. And then lastly, x to the negative 6. 1 over, correct. Cross the line, change the sign. All right? Now that on itself, usually not too bad. Now let's get crazy. This is where math usually gets frustrating. When do I have negatives? When I not have parentheses? When do I have parentheses? This is where math gets frustrating. Okay? So what I want you to do now is, I'm going to give you about a minute. Okay? Take this first column, only the first column here. Type in exactly what's right there in your that first column. Okay? Don't use the parentheses. Don't add them in. Just do exactly what's right here in that first column. Plug them into your calculator. Use those negatives right where you see them. Plug in negative 2 to the 4th, negative 2 to the 3rd, negative 2 squared. Tell me what you're getting for your answers right there on the blanks. You don't need to expand it out. Just tell me what you're getting for an answer right there. Plug it into your calculator. Fill out the first column, please. We'll come back around and talk about what's going on there. Then we'll do the second column. We're going to try to figure out a pattern of what's going on here. Why do we get sometimes negatives? Why do we sometimes get positives? This is where math gets frustrating. It's frustrating for me as well, trying to help you guys out. Okay. Give you a second. Plug those in. Decimals, graphing calculator. Just that first column. All right, you should have had a second to plug those in. Okay. And let's look at these. First thing you should notice is all those answers in column 1, we're only doing column 1. All of your answers should have been negative, correct? If you're not getting all those answers to be negative, then you can't type things into your calculator, which is half the problem.
Raise your hand and I'll come help you.
Okay, this is your time to ask, because we're going to be doing a lot of calculator work. All right, so why are all these now becoming negative? All right, so here's what's happening in your expanded form of these. Let's rewrite this in expanded form. It's not in parentheses. We'll do parentheses on the next column. Because it's not in parentheses, this is what's happening in your expanded form. Okay, when we talk about variables and solving equations, what number is hiding in front of the 2? There's a negative sign there. What else is also hiding in front of that 2? A negative 1's hiding here. This is what this means. This means it's a negative 1 times 2 times 2 times 2 times 2. This is what this means. This is what is happening here, okay? Only the 2 is getting to the 4th power. Only the 2 is getting to the 3rd power. Only the 2 is to the 2nd power. There's only a single negative out there. And only that negative 1 is going to keep that the negative. That's why we get all these negatives happening here, okay? Now, we've already talked about how we get a half and a fourth and an eighth. Now, let's go to the second column. Go now, try it again, but use your parentheses again on the second column. Type them in. Go type it in. Go type in your second column, but use those parentheses. Negative 2 to the 4th, but use those parentheses. So what I want to see from you is, come on, clear it out. All right, go clear it out. You don't have to clear it out, I guess. But parentheses, negative 2, and go to the 4th power. What did you get now? Did you get a positive, negatives, or negative 16? And then go do the next one. Negative 2, what? To the 3rd. And then go to the next one. Fill out that next column.
Then positive 4 and negative 2.
And keep going down, fill up the line there. All right.
You would do it to that power.
All right. So let's talk about this now. You get alternating signs, I believe, that just happened, didn't you?
Right.
One was positive, next one's negative. One positive, next negative. One positive, negative. One positive, negative.
Way up in
Is
the-
that your dad?
This one? We're gonna come back and talk about
Is it better?
it. Okay.
Yep, where's the number? Yeah.
So now why do we get an alternating positive, negative with parentheses? So let's go back to this again. This same thing is happening here. And what's happening here is inside of this one, because this is now in parentheses, what we do say on this one now, oops. Okay, we do want to actually put this in parentheses, that negative, because it's inside the parentheses. What do we say? 2 negatives make a,
Positive.
how many pairs of negatives do I have? One pair makes a positive and
And the rest makes
another pair makes a positive. Do I have any negatives left over? No, so all my negatives are gone, right? Dropped out. Here, because it's inside parentheses, I got 3 negatives. This pair makes a positive. Can I make a pair with that? So do I have a negative? I have a negative left over this time, don't I? That's where that negative's coming into play this time.
So it would only be the odd one instead of negative.
Yes.
Absolutely. There you go. And then on that one, boom. Right here, I got a pair. There we go. On that to the 1st power, which is a odd number, right? Can't make a pair, can I? So I'm going to have a negative left over. And doesn't that same pattern happen down here? Who cares if it's a negative exponent? All the negative exponent does is rewrites it as a fraction. It brings it as 1 over, but it's a, what? It's a even exponent, positive, odd exponent, negative. That same pattern happens, but as you said, even or odd determines that, what, positive or negative inside of there. Now Victor said, hey, I skipped over negative 2 to the 0. So let's go ahead and see what happens on that one. And what do we get? We get a positive 1. And what happened with our signs? Did it kind of continue that same alternating pattern then? There we go. All right, so let's go on ahead. So for our time's sake, let's do that last column here. Okay. On that last column, I kind of jumbled up a little bit of everything. It's the negatives on the inside that influences that. But as Chloe just pointed out, it all depends on if it's even or odd. So all I'm asking for is a plus or minus. Is the answer going to be plus or minus, positive or negative? Is this going to be positive or negative?
Positive. Negative. Positive. Negative. Positive. Negative.
You went too fast for me, Tristan. I had to double check myself. I believe that is correct. Okay? So calculators are great. Double check your work. But noticing those patterns is where we're going to be at as well. Okay? Now, on this one, do we have any parentheses? And what do we find out on this one? They were always negative. Okay? Because it's always going to be just one negative out front every single flipping time. Okay. All right. Let's take a look at the next part real quick. Flip it over, flip it over, flip it over. We're looking great on time. This is the rough day, guys. I lie. Actually, every day's rough. Okay. Let's just kind of clean everything up here then. Let's kind of go rapid fire. Again, you got calculators, so always double check your work. That's what I really want you to do. Can't do a variable, but you can do it if the base is a number. 9 squared is, boom, 81. Doing your times tables, 81. But it looks exactly the same on letter B, but it's not. I better hear something. 9 to the negative 2 becomes 1, correct. 1 over 9 squared, which is great. Or you could rewrite this as 1 over 81. And I will take either answer. Okay, either answer is great. I'm fine with either one. Okay. Okay, how about the next one? Negative, right? 81. All right, watch where that negative is located. This is a negative 81. And if you forget what we just talked about, what can you always do? Check it with your calculator. All right, now I get in parentheses, and I get a negative exponent. And if I'm not 100% sure, we can always double check it with our calculator. But that negative exponent tells me I'm going to do immediately rewriting that negative exponent as positive exponent. That is correct. And then we're right back to something that's more familiar. In parentheses, we just said even or odd. Even exponent makes it a positive 81. And I'm happy with either answer. Okay? And again, if you're not sure, what can I do? Type in that to your calculator. What do I mean by typing that in? Whatever is exactly on your paper, go right to your calculator, type in exactly what's on your calculator, hit enter. That is ugly. That is an ugly answer. How do we get rid of ugly answers? Math, option 1, change that to a fraction. Your calculator changes that back to a nice number. Okay? Desmos. All right? Desmos does that. Parentheses. Don't get lazy on me with those parentheses. Okay? AB. What is it? Negative 2, we said? Again, ugly. Change it to a fraction. Nobody should screw these up. You can always check with your calculators. Anything to the 0 power is, now the question is again, is it positive or negative? What do we see on our table? And if you're not sure, we can always go back to our calculator, but I believe it was positive. All right, finish this off here. 3 to negative 2. 1 over is what we want to see. And 1 over 3 squared or 1 over 9. 6 to the negative 1. Negative 1 is what I see in the power. Rewrite that immediately. 1 over 6 to the first. Do I need to put a 1 there though? 1 over 6. Lastly, negative exponent is what we see. That's been our big focus today. That's great. Or 1 over 16. We are happy with either one of those. Very nice. All right. Next part, kind of takes me to the next level. I've got a few extra steps in here. So let's go with number 5. All right, we're about done there, guys. I see a few extra steps. Positive exponents we are happy with. Negative exponents, not so much. So when I look at number 5, letter A, read it from left to right, just like you're reading a book. Is this base of 5? Are we good on that? Is A to the third, are we good on that? Is B to -2, are we good on that? Then move it. All right, B to -2, we know to bring to the bottom, to the denominator. But you told me 5 was fine, A was fine, but B comes down. But because 5 and A were fine, that stays up top. So then, instead of leaving it as 1 at the top, 1's now got some company. 1 has some company of 5, A to the third. And what's 1 times anything? Like, what's 1 times 5? 5. What's 1 times A? So do I need to put a 1 up there? No. 5A to the third over B squared. Okay? So let's do a couple more practices with that. B's weird. I got an x to -3 starts in the denominator. Don't overthink this, please. If we start in the denominator, now I want to make it a positive exponent. What do you think we need to do here? Switch it. Move it up to the top. Move it up to the numerator. Cross the line and change the sign. Change the sign of the power. Okay? So by starting in the denominator, cross the line, change the sign of the power. It's the same thing. Same thing. All right? Typically, we start in the numerator. Who cares? We just start in the denominator. That's it. Nothing more. We're done. Move it on. Okay. Left to right. I keep asking that same thing. Is the 4 okay? Is the 4 cool? Is the C cool? No. So the 4 you said is fine. I'm going to put up in the numerator. But the C's not. C's going to move on down below, cross the line, change the sign. Is the B cool? All right. That's it. 1 at a time. Don't bite off 2 more than you can chew, especially if you're in your phones. There you go. Okay, letter D. All right, 1 at a time, left to right. 2, is the 2 fine? All right, 2's cool. Now, there it is again. It's in the denominator. So if it's in the denominator to start with, we got to just move it up to the numerator. So now that 2's got some company, that A is coming up to the top, cross the line, change the sign. That means we have nothing left in the denominator. So we're done there. Okay. All right, let's run it across. Keep the same things that we've been doing individually. Again, stuff I'm asking you, the way I'm modeling it for you, same things I'm doing in my head when I make my answer keys. 4, is the 4 good or is it needs to change? 4 is good, isn't it? 4 is cool. How about the X? Ooh. What's anything to 0 power?
1.
So here's what's going to happen now. Anything to 0 power becomes 1. So what we're going to have here is a 4 times, not X anymore. X is gone. X becomes 1. Is the 1 okay? Or sorry, is the Y okay? Y is fine. The X is gone. What's happening here is kind of like the substitution property. X said bye, I became 1. Now let's clean this up. What's 4 times 1? And what's 4 times Y? 4Y, right? So this answer, clean that up for me. That's what I want from you. Is a 4Y. That's a cleaned up, better answer. All right, let's walk around one more time through. Letter F, is the 3 cool? No. We need to move it down to the basement, down to the denominator. Cross the line, change the power sign. X squared, is that cool or we need to move it? It's cool. That's it. Now, 3 squared could become 9. Does it have to? No. But either answer would be fine from this chemo line.
So, going back to the last problem with the x to 0.
Uh-huh.
So, if it was just any number with 0, could you just get rid of that completely and take the other number by itself?
I think so.
As long as the base is a number.
Okay, letter G. We're almost done there, guys. X to the -3. X, is that cool or not? No. Now it's in the numerator, so it's going to come down to the basement. How about that Y? It's already in the basement. Is that good, or we need to move it? It's fine. It's a power is positive, so we leave positive exponents. Hey, but there's nothing up in the numerator. There's always something hiding there. Whenever you have nothing left over, there's always a 1 there. There's always got to be something left over. And if there's nothing left over, there's always a 1 there. And last but not least. All right, one more time, left to right, top down. B, is the B good or not? No, B's moving from the numerator to the denominator. Cross the line, change the power sign. Okay, how about that bottom 3? Is that 3 good or is it moving? It's fine because it's 3 to the first right there. Power, positive power is cool. And how about that A? No, it's a negative power. Move it up to the numerator, so cross line, change the power sign. So all the A and B did was flip locations. We're good. All right, let's finish this off. Calculators for the last one. This is back to what you just did on the test with absolute values plugged into your calculator. These better be your easy rack 'em up points. Before I plug them into my calculator, you need to plug in 2 and -3 correctly in the right spots, and then we'll go to our calculator. So first thing is, hey, 3s to the third, t to -2, first better be written correctly. So s gets substituted as 2, and t gets substituted as -3. So whenever we substitute in values, guys, this is what we just did with substitution property. Plug them in the right spots, done. What we just did, I used those parentheses that we just did again with substitution property. Go to your calculator. Whatever I have in my paper there, type it in Desmos. Type it into your graphing calculator. That's why we've been doing a lot of graphing calculator and Desmos practice. Can you correctly type that in? I'm going to do the same thing, and I'll do it for both models. All right, 3 parentheses, 2, close that parenthesis to the third power. Now, again, we're all about trying to figure out how to use these calculators correctly. This is going to be very easy to screw up something with. You need to use those arrows. Are only the powers up above. And when I hit enter, did somebody get 2.6 repeating? Cool. I don't like that though. So change it from a decimal over to a fraction. And what'd you get? That's what I want to hear. Desmos people. Last one. Desmos people. Did you get the exact same thing? If you did not, this is your chance here. All right, for Desmos people. If you did not, raise your hand. Miss Keenel will come around. She'll help you. Maybe not a smile, but she'll help you. All right, and what do we got? To the -2. Boom, boom. Same thing, fraction, 8/3. All right, let's go with the last one, number 7. Okay, number 7, n becomes -2. I'm using those parentheses. W to the 0 becomes 5 to the 0. Run it in there. Last one, plug it into your calculator. You got to first correctly write it and then correctly type it. And every time I plug in these values, and you'll see it today, tomorrow, all throughout the last 3 weeks with us, we're always using these parentheses as I type it in. I will never not use those parentheses. It's just good habits we're developing right now. Oops, I forgot a -4, didn't I? Talking about good habits. So let's try this again. Second insert a negative. Somebody get, and I think it cleans up to be 1/8. Or sorry, 16th, right? 1/16. My Desmos people, you better be getting 1/16 as well. If you're not getting that 1/16, you better tell us, because that's it. Okay, that's it. That was a lot there, but we're on the right track now. Okay. All right, let's do this. Today's assignment, let's do this. We got a short amount of time. Boom, boom, boom. All right.
It's easy though. Not bad. I think we're in
Keep those calculators out because I want to quickly talk about something back to your homework. Okay? That's some old stuff that we did in the first semester. Let's get them back into play with you. Billy. And Amari. Maybe not Amari, I don't know. There we go. Just me. Amari, maybe sure. Take it one. Nope, not that tomorrow. Okay, I want to look on the back side real quick with you on the assignment. It's an old school question that's coming back into play. Let me give it a homework real quick one with you.
I filled my dirt bike yesterday. I don't have no skin and all these right.
What? Huh?
I filled my dirt bike yesterday. I don't
Oh.
have no skin and all these right.
Gotcha. All right, let's look at the back of the assignment real quick. The question I want to look at you with. Maybe did I pull it up already? Hold on.
Graph, number 9,
Yeah.
or the third column?
Nope, the graph
Okay, 9.
is number 9. Okay. Our graph of number 9 is coming kind of back into play, that exponential graph.
This is what the SAT says.
That's exactly
That's
why.
we practiced it.
How much of that have we practiced? We only did it like once, I think, right? Times like 15, 20 times, I think. Okay. A lot. Thank you.
But SAT said you had to write what you had got, and then you had to put it in a column.
Kind of like we've been practicing, right?
Ding, 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 ding.
So, that exponential curve, it comes back into play now. Because we're talking about what today? Talking about? No. Exponents.
Oh.
Oh, because now we're coming back and talking about exponential curves. So anyway, just as a kind of a quick rundown, because we're going to graph these again starting tomorrow, I believe. Similarities and differences between the exponential curve.
That one's curved, and that one is linear.
Okay, so give me a second on that. So similarities and differences. Well, one is curved, and other, and we'll say is a line. Yep, that is definitely the case. Now, what's some similarities? There you go. Very nice. Very nicely said. Let's use that math vocabulary. Both increasing. Okay. Other things that we might be able to say. Neither start from 0. Let's say start from the origin. Very nice. Anything else people got for sames or differences?
They both on the graph.
Well, that's definitely true. They're both on the graph. We'll keep on that one. Well, that's kind of a, yes, sorry.
Could you say like they both have arrows because some of them have points?
They both are continuing on to infinity. That's definitely true because we've seen the piecewise, they don't continue on. That is definitely true. Both continue indefinitely. That is definitely true. Okay. All right. So with that, just as a reminder there on some of those similarities and differences, but this is going to be now our new graph. Actually, when we just tested on last week, we're kind of done with linear land for quite a while. We kind of finally moved out of there. Now what we're going to be moving into is exponential. It's not going to be as long there for that, but exponential, and then you'll start next year and continue with exponentials because we're running out of room, and then you'll move into quadratics. Okay. All right, you got about 10 minutes here. Let's continue on that assignment. That front side, you should be able to run through pretty quickly. Do not, I would suggest losing those notes. All right, put your name at the top of those notes, save one around. And I would also encourage you to keep those notes out next to your homework as you go through things. Your notes are going to be your friend. Especially if you're stuck on things, your notes will be your friends as you go through and work on things later on, tonight, tomorrow, whatever the case is. Your notes are your buddies. Exponents only get more difficult as we work through the next couple weeks. All right. So let's work. Try it on your own.